Welcome students, let us see this question. This question says let z is equals to 1 minus cos 2 theta minus I sin 2 theta, where z belongs to complex number and theta lies between 0 to pi. So we have to find the modulus and argument of z in terms of theta and express each answer in its simplest form. So let us start this question. So z is equals to 1 minus cos 2 theta, this is its real part, minus I sin 2 theta, this is the imaginary part, sin 2 theta, right? And we have to find the modulus. So what's the condition, or what's the way of finding the modulus? We have to do the square of real part and imaginary part, adding them and taking the square root. So this is 1 minus cos 2 theta whole square plus sin 2 theta whole square. This is our modulus. And according to question, we have to write, we have to express it in simplest form. Complicated form. So what we can do, let's see. So first of all, we can expand this 1 minus cos 2 theta whole square by the identity of a minus b whole square. That is a square plus b square plus 2ab, right? So let us expand this. So a square plus b square plus 2ab, sorry, minus 2ab. So it will be minus 2 cos 2 theta plus this is sine square 2 theta. And as we know, this cos square 2 theta plus sine square 2 theta will become 1. So this will be 1 plus 1, that is the 2 minus 2 cos 2 theta, right? So from here we can take 2 as a common and we can write this as 1 minus cos 2 theta. And we have a formula for 1 minus cos 2 theta. We have a formula 1 minus cos 2 theta is equals to 2 sine square theta. So when we apply this formula, so we can write 1 minus cos 2 theta, that is the 2 sine square theta. So this 2 will become outside of square root and sine square theta will give us sine theta. So this is the modulus of this z, and this is in its simplest form. So we get the answer of the first part, and we have to find the argument for z also, argument of z also. So what is the argument? It's the angle. So let argument is alpha, right? So we have to find alpha, and we know tan alpha is what? It's imaginary part upon real part. What's the imaginary part of z? Imaginary part of z is minus sine 2 theta. So please write minus sine 2 theta upon what's the real part? 1 minus cos 2 theta. So it's 1 minus cos 2 theta. Basically this is more about trigonometrical question. There is very little concept used from complex numbers, right? Most of the concept, most of the core solution belongs to your trigonometrical part. So we have to simplify this expression. So again we can write this minus sine 2 theta can be written as minus 2 sine theta into cos theta. I have used the multiple angle formula upon 1 minus cos 2 theta. It is written here. That is the 2 sine square theta. This 2 and 2 will get cancelled out. 1 sine theta will get cancelled out. So we are getting minus cos theta upon sine theta, which is minus of cot theta. So see, we have tan alpha is equals to minus cot theta. So can we compare right now? No. Why? Because here it's tan and in the right hand side it's cot. So we have to convert this in terms of tan. So we can write tan alpha is equals to minus cot. We can write this pi by 2 minus theta. As we know, cot pi by 2 minus theta is equals to, sorry, we can write it tan pi by 2 minus theta. We can write here as tan pi by 2 minus theta, because we know tan pi by 2 minus theta will be your cot theta, right? So what we can do now, see, this minus can also be adjusted in angle, as we know that the tan theta and cot theta are the odd functions. So we can write here tan alpha is equals to tan of theta minus pi by 2, because tan theta and cot theta both are basically odd function. What is the odd function? The meaning of odd function is tan of minus theta, you can write minus tan theta. So similarly from this side to this side, this is the odd function. Now can we compare? Yes, we can compare now. This is tan, both are equal. So we get alpha is equals to theta minus pi by 2. So we get the argument as well. So this complete our first part. See, we have to find modulus and argument of z in terms of theta and in its simplest form. We have done this. Next part is saying find the cube root of z in modulus argument form. We have to find the cube root of z. So let us see how we can do this. We have to find the cube root of z. So first of all, what was my z? Z can be written in modulus argument form as mod z into e raised to power I alpha, right? This is the modulus argument form. So mod z is what? Mod z was, we have finded this, it was 2 sine theta. So we can write 2 sine theta, this is the mod of z, into e raised to power I. What was my alpha? Alpha was theta minus pi by 2. So we have to write here theta minus pi by 2, right? So this is the complex number z in its modulus argument form. Now, according to the question, we have to find z raised to power 1 by 3. That is the cube root of z. So what we have to do? Simply, we have to do 2 sine theta e raised to power I theta minus pi by 2. This is the z, and this whole power 1 by 3. Now, we know that this power will go into its angle. So we can write here 2 sine theta raised to power 1 by 3 into e raised to power I theta minus pi by 3 upon 3, right? This power goes into angle. So this will be 2 raised to power 1 by 3 sine theta raised to power 1 by 3, and this will be e raised to power I. We can write theta minus pi by 3. Sorry, why pi by 3? This is pi by 2. Basically, this was pi by 2. So this was pi by 2. Sorry, it's my bad. Pi by 2 upon 3. This, right? So this is cube root of z. But as we know that the cube root should have the 3 roots, so how we can get the 3 roots? So we can generalize this term. We can write this in generalized form. So we can write this in form of 2 raised to power 1 by 3 into sine theta raised to power 1 by 3 into this can be e raised to power I theta. You know what is the e raised to power I theta? E raised to power I theta is equals to cos theta plus I sine theta, right? First write this in this form. So this will be cos theta minus pi by 2 upon 3 plus I sine theta minus pi by 2 upon 3. This is our e raised to power I theta. Now, we have to write its general expression. Then we can find the 3 roots. So, we can write this 2 raised to power 1 by 3 into sine theta raised to power 1 by 3. Now, this can be written as cos this theta minus pi by 2 plus 2n pi, this whole divided by 3, plus I sine theta minus pi by 2 plus 2n pi by 3, right? How I have written this? Because after 2n pi addition or rotation, the angle will be same, right? We can convert directly before dividing by 3, or we can write after dividing by 3 also. Both are correct, no way, no doubt. Okay, so what will be the answer? I think this is my answer. When we will put n different values of n, we will get the different value of z. Let us put n is equals to 0 here. So what we will get? We will get first root as z is equals to 2 raised to power 1 by 3 sine theta raised to power 1 by 3, and this will be cos theta minus pi by 2 upon 3 plus I sine theta minus pi by 2 upon 3. We have put a value of n as 0. So this is the first answer. Similarly, when we put n is equals to 1, we will get z2 is equals to 2 raised to power 1 by 3 sine theta raised to power 1 by 3, and here we will get cos, put n is equals to 1, so it's 2 pi minus pi by 2. What it will be? We will take the LCM, this 2, this 4 pi minus pi, that is the 3 pi by 2. So we will write here theta plus 3 pi by 2 upon 3 plus I sine theta plus 3 pi by 2 upon 3. This is the second solution. Let us see the third. When we put n is equals to 2, what we will get? Let us see. Let us put n is equals to 2 here. So we will get z3 is equals to 2 raised to power 1 by 3 sine theta raised to power 1 by 3, and this will be cos, what it will be? We have to put n is equals to 2. So when we put n is equals to 2, it's 4 pi minus pi by 2. It's 4 pi minus pi by 2. So this will be, when we will, it's 8 pi, 7 pi by 2, right? 7 pi by 2. So we will get, sorry, theta plus 7 pi by 2 upon 3 plus I sine theta plus 7 pi by 2 upon 3, right? Now we get the 3 roots, but there is one condition we need to check, that is our theta must be, or we can say our theta is lying between 0 to pi. So yes, there is no problem. We can find theta is equals to 0 to pi. We can put any value of 0 to pi. So we will get the three roots at Z1, Z2 and Z3. So I hope you have understood this question. If you like this solution, please like this video, subscribe this channel. Thank you. Thanks for watching.